Okay, this is one more in our series of everybody's favorite chemistry topic, stoichiometry, and this one we're going to do grams to moles. So we're going to be given the grams of one of the substances in our chemical equation, and we're going to figure out how many moles we need to produce that many grams, or how many moles of the other product we're going to produce. Okay, so we're going to be given 1 gram, and we're going to figure out the rest in moles. All right, so let's go ahead and look at our chemical equation. You can see here we have a single replacement of aluminum and copper chloride. We're going to be given 8.25 grams of copper chloride, and we want to know how many moles of aluminum do we need to react that many grams, and how many moles of copper and how many moles of AL-Cl3 aluminum chloride we're going to produce. Okay, please remember that a chemical equation is a molar relationship, not a mass or a gram relationship. You can see it basically says here that 2 moles of aluminum plus 3 moles of copper chloride will yield 3 moles of copper and 2 moles of aluminum chloride. You can think of it as atoms or particles or atoms or molecules, but I like to think of it as moles because that's usually the way we work with it in the lab. Okay, so you remember that we said there are 3 steps to every good stoichiometry problem, and in this case we're going to use 2 of them, but let's just run through all 3. The first step is we're going to convert from grams to moles using the molar mass. So we've been given grams. The chemical formula is a molar relationship, so we have to convert this from grams to moles. So step 2, we're going to use the molar ratio between the copper chloride and the other 3 to determine the moles of the substance that we're either going to need or produce. And if we wanted to, but we're not going to in this video, then we can convert the moles into grams using the molar mass. Okay, so as I said in this video, we're just going to do steps 1 and step 2. In previous videos, we've gone through the other steps, so you can see those if you'd like. But let's go ahead and get started. And we said step 1 is to convert from grams to moles. So we're going to convert 8.25 grams into its corresponding moles. Here we wrote down, as you should, the number, the unit, and then the chemical formula. Of course, we're going to use the molar mass. So the molar mass of copper chloride is 134.45 grams. That is equivalent to 1 mole. So here we have our molar mass, which allows us to cancel. We put the grams on the top over here, put the grams on the bottom over here, and that will allow us to cancel, and now we're in moles of CuCl2. Okay, so that's the number of moles. And I like to write it up here so I can see that these 2 go together. This is the mass, this is the corresponding number of moles. And now we're going to use this number of moles to do a molar ratio and convert from moles of CuCl2 first to moles of aluminum, then to copper, and then to AL-Cl3 aluminum chloride. And we're going to do that on the next slide, but we're going to use that value, the 0.614 3 times. All right, so let's go ahead and do that. Okay, so here's our mass of the copper and our corresponding moles that we were given, the copper chloride. And we're going to use that. See, I wrote down the number, the unit, and the chemical formula. And now we're just going to use the molar ratio. This would be step 2 in our 3-step process. We want to get out of the moles of copper chloride, so that goes in the bottom. We want to get into the moles of aluminum. We'll do that one first. The 2 to 3 ratio. So you can see we put the 2 in front of the aluminum from the coefficient up here. The 3 goes in front of the copper chloride, and that allows us to cancel moles of copper chloride, and that tells us now we're into moles of aluminum. And that means it's 0.0409 moles of aluminum. So that tells us how much aluminum. So in order to react 8.25 grams, or this many moles, we would need 0.0409 moles of aluminum. Now we're going to do the same thing, not 3 more times, but 2 more times. This being step 2, using our molar ratio. We start always with the moles, not always, you don't have to, but I think it's good just to start with the moles of the substance you've been given. We could use this one, of course, but let's just be consistent. We know the moles of copper chloride goes in the bottom, the moles of copper goes in the top, and you can see this is a 3 to 3 ratio, basically 1 to 1. So the number of moles of copper chloride and the number of moles of copper produced are the same. They won't be the same mass because they have different molar masses. But we're going to put 0614 moles of copper. Okay, we just have one more. We're going to start again with the 0.0614 moles of copper chloride. Write down our railroad tracks, copper chloride in the bottom, aluminum chloride in the top, molar ratio, 3 to 2, 2 to 3, and we can cancel the moles, and we see that that is going to be 0.0409. And you'll notice that this value and this value are the same because this is a 2 and this is coefficient of 2. So that's basically 2 to 2, or if we reduce that, a 1 to 1 ratio. Okay, so the first thing we did on the first slide was convert 8.25 grams into its moles, and then we used the same number of moles of the copper chloride and the molar ratio between the copper chloride and the other three, the aluminum, the copper, and the aluminum chloride, to convert into the number of moles, that being step 2. We're not going to convert from moles to grams in this video, okay? But we have done that in previous videos, which you can watch. All right, so thank you very much. I hope that was helpful. If that was, if you also thought that was helpful, then maybe give me a thumbs up down below in the comment section. And thanks for watching, and we will see you next time.